Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 5, Chance Experiments with Outcomes that are not equally likely. Okay, here's the classwork. In previous lessons, you learned, I am not going to say that, you should have learned, I'm not certain you have, but so I can't say that. In previous lessons, you should have learned that when the outcomes in a sample space are equally likely, the probability of an event is the number of outcomes in the event divided by the number of outcomes in the sample space. However, when the outcomes in the sample space are not equally likely, we need to take a different approach. And that, my friends, is chance experiments with outcomes that are not equally likely. So here's example 1. When Jenna goes to the farmer's market, she usually buys bananas. The number of bananas she might buy and their probabilities are shown in the table below. I can picture minions saying that when I read that. Okay, so we have the number of bananas, 0, 1, 2, 3, 4, 5, and the probability of getting 0 bananas is 1/10 or 0.1. Probability of getting 1 banana is 1/10, 2 bananas 1/10, 3 bananas 2/10, 4 bananas 2/10, 5 bananas 3/10, 3/10, 5/10, 7/10, 8/10, 9/10, 10/10. So this bottom row adds up to 1 or 10/10. Okay. What is the probability that Jenna buys exactly 3 bananas? Probability is 2/10. Okay, or 0.2, or 20%. Okay, what is the probability that Jenna does not buy any bananas? That's right here. 1/10, or 0.1, or 10%. What is the probability that Jenna buys more than 3 bananas? So I'm going to, sorry about that, I'm losing it. Buy more than 3 bananas, it is right here. More than 3 is up here, so it'd be buying more than 3 bananas would be buying 4 plus the probability of buying 5. Okay, so let me do that. The probability of 4 plus the probability of buying 5. I'm going to show my work. The probability of 4 plus the probability of 5. Well, the probability of 4 is 0.2. The probability of 5 is 0.3, and that equals 0.5, or 5/10, or 50%. Okay. D. What is the probability that Jenna buys at least 3 bananas? Okay, at least 3. What does at least mean? At least means greater than or equal to. Greater than or equal to. Many of you did not use this knowledge on the test we just took, and you don't know your inequality symbols. At least. I asked for an inequality, and I said at least, and people don't know this. At least means greater than or equal. Greater than or equal means at least. Well, what's greater than or equal to 3? 3, 4, and 5. So I'm going to take the probability of getting 3 bananas and add it to the probability of getting 4 bananas plus the probability of getting 5. I missed my accent there. Probability of 5 bananas. So the probability of 3 is 0.2, the probability of 4 is 0.2, the probability of 5 is 0.3. Those add up to 0.7, or 7 out of 10, 7/10, or 70%. Okay, oops, I did not want to do that. E. What is the probability that Jenna does not buy exactly 3 bananas? Okay, the word there that's key is does not. So I'm going to take this 3. So if I don't buy 3 bananas, the probability of not buying 3 bananas is everything but 3. So it's the probability. Bear with me. I'm going to show all my work. I'm going to be tedious here, okay? But I'd like to drive home the concept behind this, the process. So the probability of not buying 3 means the probability of buying everything but 3, or the probability of buying none, the probability of buying 1, the probability of buying 2, the probability of buying 4, plus the probability of buying 5. So the probability of 0 is 0.1, plus the probability of 1 is 0.1, plus the probability of 2 is 0.1, plus the probability of 4 is 0.2, plus the probability of 5 is 0.3, 3, 4, 5, 6, 7, 8. That is 0.8, or 8 out of 10, or 80%. Okay, it says here, notice that the sum of the probabilities in the table is 1 whole. And I've already said that. I said that at the beginning. This is always true. When we add up the probabilities of all possible outcomes, the result is always 1. So taking 1 and subtracting the probability of an event, giving us the probability of something not occurring. Okay, so that's what we're leading up to in this problem. Rather than adding all those up, all I had to do was take the total 1 and subtract this 0.2. Well, 1 minus 0.2 is 0.1. Okay, enough said about that. Page 2. Did I go just 2? Yeah. Page 2. Exercise 1. Jenna's husband, Rick, is concerned about his diet. On any given day, he eats 0, 1, 2, 3, or 4 servings of fruits and vegetables. The probabilities are given in the table below. On any given day, find the number of probabilities that Rick eats A, 2 servings of fruits and vegetables. The probability of 2 is right here, so it's 0.28. Let me do that. The probability of 2 equals. Okay. B. Let's get rid of this. B. Find the probability that Rick eats more than 2 servings of fruits and vegetables. More than 2 is 3 or 4. So I'm going to say the probability of greater than 2. It's the greater than symbol. The probability, not 72, let me write that a little bit better. The probability of greater than 2 equals the probability of 3 plus the probability of 4, which equals 0.39 plus 0.12, and that equals 0.51, or 51%, or 51 100ths. C. What is the probability that Rick eats at least 2 servings of fruits and vegetables? At least 2. Again, I have to stress this. At least is greater than or equal to. Greater than or equal to 2 is 2, 3, or 4. The probability of greater than or equal to 2 equals the probability of 2 plus the probability of 3 plus the probability of 4, which equals 0.28 plus 0.39 plus 0.12, which equals 8 plus 9 is 17, plus 2 is 19, carry the 1, 2 plus 3 is 5, plus 1 is 6, plus the carry is 7, 2, okay, so that's it, 79, 0.79, or 79 over 100, 79 100ths, or 79%. 2. Find the probability that Rick does not eat exactly 2 servings of fruits and vegetables. Does not eat exactly 2. That means 0, 1, 3, or 4. So remember, in that last example, they told us that the total probability, this bottom, always equals 1. So the probability is going to be 1 minus the probability of beating 2, if you will. Okay? That's not the probability of 1 minus the probability of beating 2. Equals 1 minus the probability of beating 2 is 0.28. So the probability of not exactly 2 is 72. 0.72. Or 72 hundredths. Or 72%. Okay? Okay, example 2. Luis works in an office, and the phone rings occasionally. The possible number of phone calls he receives in an afternoon and their probabilities are given in this table. So the first thing I'm going to do is see if this equals 1. 1 6, 1 6, 2 ninths, 1/3, 1 9. My denominators are not the same. I can't just simply add them. I need to find a common denominator. What are common multiples of 3 and 6 and 9? Okay, I see it now. See what I just did? 3, 6, 9, 12, 15, 18. 6, 12, 18. 9, 18. I'm looking for the least common multiple, 18. So I need to get a denominator of 18. So 1 6 is 3/18. Plus 1 6 is 3/18. I'm doing these here. 2 ninths is 4/18. 1/3, I have to multiply 3 by 6 to get 18, so it's 6/18, and 2 ninths, or 2/18. So 3, 6, 10, 16, 18 equals 18/18. Check, that equals 1. Alright, I agree, so I'm going to continue now. I don't always trust given things. I've got to make sure for myself. So that probability adds up to 1, which is what we want. Find the probability that Luis receives 3 or 4 phone calls. Probability he receives 3 or 4. Okay, so we're going to, I should have left those up there. Our common denominator in this case would be 9. So 1/3 is 3 ninths. So the probability of 3 or 4 equals 1/3 the probability of 3 plus the probability of 4, which is 1 ninth, which is 3 ninths plus 1 ninth, which equals 4 ninths. B. Oh, I love it when they go to the new page. Fantastic. Alright, so now we have to work with this same table and go back and forth answering questions. Now it says to find the probability that Luis receives fewer than 2 phone calls. Now I have to go back here, go down here. Fewer than 2 is 0 or 1, and they're both 1/6. So I'm going to say the probability that it is going to be less than 2 equals, so parentheses by the way, equals the probability of 0 plus the probability of 1. And the probability of 0 phone calls was 1/6. The probability of 1 phone call was 1/6. They add up to 2/6, and that is the probability of 1 out of 3 or 1/3. Or C. Find the probability that Luis receives 2 or fewer phone calls. 2 or fewer. 2, 1, or 0. So 2, 1, or 0 would include these 3. So 1/6, 1/6, 2 ninths. Okay? So the probability of being less than or equal to 2 equals the probability of 0 plus the probability of 1 plus the probability of 2. Alright, I already did 0 and 1, it's here. 1/6 plus 6 plus, and 2 was 2 ninths. Okay, plus 2 ninths. I need common denominators, so it's 18. 1/6 is 3/18. 1/6 is 3/18. 2/9 is 4/18. Add them up. 3 and 3 is 6, plus 4 is 10 out of 18, or 5 out of. Alrighty. Find the probability that Luis does not receive 4 phone calls. The probability that he does not receive 4 phone calls is 1 minus receiving 4 phone calls. Remember that little trick? If this adds up to 1 and we take that away, these 4 add up to my answer, and it's the same as 1 minus this, 1/9. So, the probability that he does not receive 4, that's the symbol for not, a little squiggly. The probability of not 4, actually, let's not introduce that yet. Let's just do this. The probability of not 4 equals the probability of, not the probability of 1, it's just 1. The probability of not 4 equals 1 minus the probability of 4. So 1 minus, and then I go back and look, oops, wrong way, try that again. Probability of 4 was 1/9, so it's going to be 1 minus 1/9, or 9/9 minus 1/9 equals 8. Okay? Exercise 3. Now you try this one. Pause the video, see if you can get this, and come back and we'll share. Okay, so I have a 12, I have a 6, I have a 12, I have a 4, I have a 12. The common denominator is 12, so I'm going to do 1/12 here, 2/12 here, 5/12 here, 1/4. I have to multiply by 3 to get a 12, so it's 3/12, and 1/12. 5, 6, 7, 8, 9, 10, 11, 12. That equals 12 over 12, which equals 1. Check. All right. When Jenna goes to the farmer's market, she also usually buys some broccoli. The possible number of heads of broccoli that she buys and the probabilities are given in the table below. The probability that she doesn't buy one is 1 out of 12. Buying 1 is 1 out of 6. She buys 2 quite frequently, 5 out of 12. She buys 3 out of 12 times, and 4, 1 out of 12 times. So what is the probability that she buys exactly 3? So exactly 3 is right there. So the probability of 3 equals a 4. It's easy. Does not buy exactly 3. P not 3 equals 1 minus the probability of 3. 1 minus a quarter equals 3/4. Okay? Buys more than 1. More than 1 is 2, 3, 4, 5. More than 1 is these. I'm going to focus on these values down here, though. So the probability of more than 1 equals the probability of 2 plus the probability of 3 plus the probability of 4. The probability of 2, and I'm going to use these values down here so I can add them, is 5/12. The probability of 3 is 3/12. The probability of 4 is 1/12. Add my numerators, and I get 9/12, which is 3/4. All right. Buys at least 3. Buying at least 3 means 3 or more. The symbol for at least is greater than or equal to. The probability of more than or equal to 3 equals the probability of 3 plus the probability of 4, which equals 3/12 plus 1/12, which equals 4/12, which equals 1/3. Booyah! Alright, next one. The diagram below shows a spinner designed like the face of a clock. The sectors of the spinner are colored red. Blue, B, green, G, and yellow. Right? So they've split this up into sectors. So how about I just color code this for you? This section is red. This section here is blue. Green is here. and yellow, which you probably won't be able to see very well. It's right there. Okay, so there we go. I color-coded for you. Now it says, write your answer as a fraction in lowest terms. Find the probability that the pointer stops in the following colors. Probability of red. Well, if this is a clock, then there should be 12 sections. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 sections between each 5-minute marker. Okay, writing your answer as fractions in lowest terms. What's the probability it's red? 1 out of 12 sectors. Okay. Blue. That is 2 out of 12. Go back and read the question. Right here. Find the probability the pointer stops in the following colors. Write your answers as fractions in lowest terms. A lot of people don't read the directions. Lowest terms. Notice I'm getting frustrated with not reading directions. It is now almost the end of the school year and students are still not reading directions. 6th. Green. 1, 2, 3, 4, 5. 5 out of 12. Cannot be reduced. Yellow. 1, 2, 3, 4. 4 out of 12 reduces to 1/3. Okay. Complete the table of probabilities below. All right. Now it's just asking us to put these answers we got up here down here. So red was 1/12. Blue was 1/6. Green was 5/12. Not 5/10. 5/12. And yellow was 1/3. But if I add up the 12s before reducing, 1, 2, 3, 5 is 8, 4 is 12, I get 12 12s, which equals 1. 6. Find the probability that the pointer stops in either the blue region or the green. The probability of blue or green equals the probability of blue plus the probability of green. Now that we're on a new page again, probability of blue is 1/6, but I am going to add, so I need common denominators, so I will use the unreduced version. Probability of blue, the probability of green. 2 12s, 5 12s. Equals 7 12s. Find the probability that the pointer does not stop in the green region. Does not. The probability of not green equals 1 minus the probability of green. So it's going to be 1 minus, I already did green right here, it's 5 12s. And 1 is 12 12s. Minus 5 12s equals 7 12s. Okay, that is the end of lesson 5. Read the summary, go do your problem set.